Imagine you are standing at the threshold of an open hatch, directly beneath your feet, 300 kilometers of absolute void, and below that, the endless blue of the Earth. Today, you are leaving. And this is not just a short trip to the ISS. You are heading out to where the influence of our sun ends and the eternal darkness begins. Most of us are used to measuring distance in miles or kilometers, 5 miles to the office, 500 miles to another city. But in space, kilometers mean nothing. Here, the only currency is time. We often see beautiful maps of the solar system in textbooks. The planets are lined up there, like balls on a billiard table. This is the greatest lie in the history of science. If the Earth were the size of a grain of sand, then Jupiter would be 3 blocks away, and Pluto 6 miles away, and between them, nothing. Only vacuum and silence. Today, we set out on this journey. We will follow in the footsteps of legendary spacecraft, which spent decades just to take a single photograph. We will find out why a flight to our closest neighbor, Mars, is a complex logistical loop that can only be opened once every 2 years. But the most interesting part begins at the end. We will ask, what if we could travel at the speed of light? Spoiler, even in that case, the cosmos will make you wait. Get ready. We are leaving home. And the first thing you need to understand is that coming back might not be an option. Ahead lie millions of hours of travel. Welcome to the guidebook for the longest route in human history. Your journey begins not into the void, but toward a blinding light. Logic suggests that reaching the nearest neighbors of the Earth should be the easiest. But in space, logic often burns up in the solar corona. Mercury is 3 times closer to us than Jupiter. But the paradox is that sending a spacecraft to this small, glowing planet is technically harder than flying out of the solar system. Why? The answer lies in gravity. Imagine that the sun is a giant funnel. The Earth rotates along its edge at a high speed, about 30 kilometers per second. To go lower, toward Mercury, you do not just press the gas, you need to brake. You need to kill that colossal energy that the Earth gives you. It is like trying to take a turn in a race car that is hurtling downhill. If you just fly in a straight line, the sun's gravity will grab you and throw you straight into the fiery abyss. Therefore, a flight to Mercury is an endless dance of braking. The Messenger spacecraft flew to its target for 6.5 years. 6.5 years to cover a distance that light travels in 5 minutes. It made 15 orbits around the sun before it could safely enter orbit. But even in this hell, there are records. Right now, the Parker Solar Probe is in space. It does not land on planets, it studies the sun itself. And it is the fastest object ever created by man. Its speed reaches 700,000 kilometers per hour. Let us take a second to realize this number. If an ordinary passenger plane flew at this speed, it would make a trip around the world in 4 minutes. A flight from New York to London would take less than 40 seconds. But even with such incredible power, Parker needs years to perform its maneuvers. In space, speed is not only freedom, but also shackles. On the way to Mercury, we pass Venus, our evil twin. It is much faster to reach, an average of 4 months. This is the shortest route in the solar system. The Soviet Venera spacecraft reached it in 120 days. But travel time is only half the problem. When you reach Venus, you will understand why no one is in a hurry to send people there. You will spend 4 months in a comfortable capsule only to face pressure that will crush your ship in seconds and a temperature of 470 degrees Celsius at the end. Your journey turns into a race against time. How long will the equipment last? The record is only 127 minutes. We spend months on a flight to get 2 hours of data. This is the price of exploring the inner planets. Here, time works against you. It melts metal and burns out electronics. You look out the window, and the sun here seems like a huge, pulsating monster. You realize that humans here are just uninvited guests. To survive and continue the journey, we need to turn around. We need to run from this heat to where a cold, rusty desert awaits us. We turn the ship around and leave the sun behind. Ahead is Mars, the planet that we are used to considering our second home. In mass culture, a flight to Mars looks like a simple walk. We are used to headlines about colonization, about cities under domes. But when it comes to reality, time again takes its toll. The distance to Mars is constantly changing. When we are on one side of the Sun and Mars is on the other, 400 million kilometers separate us. When we get closer, this distance is reduced to 55 million. It would seem you just need to wait for the moment of convergence and jump. But in space, you cannot fly in a straight line. If you aim where Mars is today, by the time you arrive, there will be an empty void. Mars will run ahead in its orbit. Therefore, the flight turns into a complex interception. It is like throwing a football on the run to another player who is also rushing at full speed. We use the so-called Hohmann transfer orbit. This is an elliptical arc that allows you to save fuel. You use the inertia of the Earth so that it literally pushes you toward the Martian orbit. The average travel time with current technology is from 7 to 9 months. 300 days in a metal box the size of your kitchen. 300 days during which the Earth turns from a huge ball into a tiny blue spark and then disappears altogether among thousands of other stars. And here lies the main catch of this part of the path. Mars is not a neighboring street where you can turn at any moment. It is another country where the bus only runs once every 2 years. This is called a launch window. If you did not have time to start the engines in these short few weeks, you will have to wait on Earth for another 780 days. And if you have already arrived on Mars and decided that you do not like it there, you will not be able to fly away the next morning. You will have to live on this rusty rock for 1.5 years, just waiting until the planets line up again in the right configuration for the return home. 7 months of travel there, 18 months of waiting, 7 months of travel back. One expedition to Mars is 3 years of your life. This is the time during which children are born on Earth, governments change, and trends are forgotten. But Mars is only a frontier. While we are discussing a 9-month flight, the real titans of the solar system are laughing at our impatience. Because beyond Mars, the territory begins, where time is measured not in months, but in decades. We pass by the Martian moons, Phobos and Deimos. Ahead is the asteroid belt, thousands of stone fragments that once could have become a planet, but remained the construction debris of the system. We enter the zone of silence. We leave Mars behind. Now our journey moves to a different level. Between Mars and Jupiter lies the asteroid belt. Hollywood has taught us that this is a deadly labyrinth of stones where the pilot needs to constantly maneuver. But the reality is much more deserted. The average distance between 2 asteroids is about 1 million kilometers. You can fly through this belt with your eyes closed and never hit anything. The real danger here is not in a collision. The real danger is the cold. We are crossing the so-called snow line. Here, sunlight becomes so weak that it can no longer warm the metal of your ship. At such a distance, solar panels the size of a basketball court produce as much energy as an ordinary light bulb. To fly further, we need nuclear batteries. And so, after 1.5 years of travel, he grows ahead. Jupiter, the largest planet in our system. This is not just a celestial body. This is a monster, whose mass is 2.5 times the mass of all other planets combined. If you are flying on a modern spacecraft like Juno, the journey to Jupiter will take you about 5 years. This is a long and tedious wait. But Jupiter is worth it. He is our main ally in the journey to the outskirts. It is here that we use the main trick of space navigation, a gravity assist. Imagine Jupiter as a giant invisible hand. When your ship approaches him, the planet begins to pull you into its gravity well. You accelerate. You are falling toward Jupiter, but you do it at a certain angle. You rush past, and Jupiter's gravity, like a slingshot, throws you forward with monstrous force. Here, something happens that few people think about. At this moment, a planetary scale theft occurs. To accelerate your ship, Jupiter gives you a tiny part of its orbital energy. You become faster, and Jupiter slows down just a little bit. If we launched millions of ships in this way, we would eventually stop Jupiter's rotation around the Sun. No, for now, we just use its generosity. The New Horizons spacecraft, using this kick from Jupiter, accelerated to 45,000 kilometers per hour. This allowed it to shorten the path to the edge of the system by as much as 3 years. But even with such speed, space begins to win. Jupiter remains behind, becoming just another bright dot in the sky. We are entering a space where distances begin to frighten. Ahead, Saturn awaits us, and if we flew 5 years to Jupiter, then the path to the rings will make you truly realize what loneliness is. After Jupiter gave us acceleration, we enter a space that can only be described in one word: void. The distance between Jupiter and Saturn is almost the same as the distance from the Sun to Jupiter. It is as if we are moving from one room to another, but this hallway is stretched for hundreds of millions of kilometers. If you were flying on the legendary Cassini spacecraft, your journey to Saturn would take 7 years. 7 years is not just a number. During this time, a child has time to go to school and finish the first grade. During this time, technologies on Earth have time to become obsolete. When Cassini started, the internet was still transmitted through phone wires, and when it arrived at Saturn, the world was already living in the era of smartphones. It is a strange feeling. You are flying in a time capsule. Inside your ship, technologies of the past, and ahead, eternity. And the further you go, the thinner your connection with humanity becomes. Here we are faced with what scientists call signal delay. When you are at Saturn, radio waves, traveling at the speed of light, take about 80 minutes to reach Earth. The same amount of time is required for the answer to return to you. Imagine that you are faced with a problem. You send a signal. We have a failure in the cooling system, and you wait. An hour passes, an hour and a half passes. During this time, engineers on Earth have time to drink coffee, discuss options, and send you a command. But by the time you receive it, almost 3 hours will pass. In deep space, you cannot ask for help. You are absolutely, totally alone. Any mistake that you cannot fix yourself will be your last. But when Saturn finally appears in the window, all those years of waiting seem justified. Its rings are not just stripes on a disk. This is a colossal structure of ice and stone, stretched over hundreds of thousands of kilometers, but at the same time thin, like a sheet of paper on the scale of a planet. You look at Enceladus, a small, icy moon of Saturn, from under the surface of which giant geysers hit. You realize that you are in a place where time flows differently. Here, 1 year lasts 30 Earth years. If you decide to stay here and wait until Saturn makes a full circle around the Sun, you will return to Earth as an old man. Saturn is the last planet that a person can see in the night sky without a telescope. Further begins a territory that ancient astronomers did not even suspect. We cross an invisible line. We are going where the Sun becomes just a very bright star, unable even to light the way. We cross the border, beyond which sunlight finally loses its power. Uranus and Neptune. We call them ice giants, but in fact, we know almost nothing about them. In human history, there was only one spacecraft that saw these worlds up close. Voyager 2. The journey to Uranus takes about 9 years, if you are lucky with a gravity assist. 9 years of flight for the sake of several hours of convergence. When Voyager flew past Uranus in '86, it discovered a strange world that literally lies on its side. Its magnetic poles are shifted, and the rings, unlike Saturn's, are black as coal. But Uranus is only the entrance to the real abyss. Further lies Neptune, the last official planet of our system. To reach it, Voyager needed 12 years. 12 years of continuous movement in the void. At such a distance, the Sun looks not like a disk, but like just a very bright star. It shines, but it no longer warms. The temperature here drops to -220 degrees. This is a place where time itself seems frozen. And here we come to our point. A journey to the outer planets is not just a technical challenge. It is a challenge to human life itself. At NASA and other space agencies, there is a concept: generational missions. Imagine a young engineer who, Immediately after university, comes to work on a mission project to Neptune. He spends 5 years designing and building the spacecraft, then the launch. And for the next 12 or 15 years, he just waits. He comes to the office every day, checks the telemetry, while his children grow up, go to school, and finish it. By the time the spacecraft finally reaches its goal and sends the first clear shot of the planet, this engineer is already preparing to retire. Many of those who started the Voyager missions have already passed away, never knowing where their creations are now. We send not just metal into space, we send decades of human lives there. This is a kind of sacrifice of time for the sake of a grain of knowledge. Why haven't we flown to Neptune again? Because for this, you need the perfect arrangement of the planets, which allows you to use the gravity of Jupiter and Saturn as accelerators. Such a window opens only once every 175 years. The next time we can repeat this maneuver will only be in the middle of the 22nd century. Neptune meets us with monstrous winds, the fastest in the solar system. Supersonic gas streams race in the dark, where there is no day, no night. We look at this blue ball and understand that this is the final. Further, only darkness and rare ice rocks. We have officially left the planet zone, but ahead of us is something that for a long time was considered the ninth world and has now become a symbol of our persistence. Pluto. And the path to it will make us reconsider everything that we knew about speed. We have passed the orbit of Neptune. Beyond this invisible line, space changes. Here begins the Kuiper Belt, a huge cemetery of icy worlds left over from the birth of our system. And among them is an object that for a long time was our ninth planet, Pluto. To understand how big the cosmos is, you need to look at the New Horizons mission. This spacecraft left Earth in 2006 with incredible speed. It flew past the moon just 9 hours after launch. For comparison, it took 3 days for the Apollo astronauts to do this. But even with such crazy speed, the path to Pluto took 9.5 years, 9 years of silence for the sake of one flight lasting a few hours. Pluto turned out to be not just a gray piece of ice. We saw mountains of water ice as high as the Alps and a giant nitrogen heart on its surface. But as soon as the spacecraft took the pictures, it continued its flight into the void. It had no way to stop. Pluto's gravity is too weak, and the ship's speed is too high. You look back. The sun is now just a dot. It no longer lights your path, it just reminds you where your home stayed. And here, most people make a mistake. We are used to thinking that Pluto is the end, that interstellar space begins beyond it, but this is not so. Beyond Pluto lies a real wall. We are entering the Oort cloud. This is a giant spherical shell of icy fragments that surrounds our entire system. If we take the distance from the Earth to the Sun as 1 meter, then the edge of the Oort cloud will be 100 kilometers away from us. To overcome this space at current speeds, we will not need years or decades, we will need millennia. It will take Voyager 1 about 300 years just to reach the inner edge of this cloud, and another 30,000 years to exit on its other side. Think about it. 30,000 years. All of human civilization, from the first rock paintings to the launch of the internet, fits into this period of time. We have sent spacecraft that will leave our home only when humanity itself, perhaps, changes beyond recognition or disappears. Here, on the outskirts, time stands still. You are in a place where the sun's gravity is barely perceptible. Your ship is slowly dying. The radioactive fuel in its generators is being exhausted. The signal from Earth becomes so weak that it is almost impossible to distinguish it from the noise of the universe. Pluto is the last stop, where we could still distinguish the details of the landscape. Further, only mathematical calculations and theories. We are standing on the shore of a great ocean. And if we want to cross it during the life of one generation, we need something more than just burning fuel in rockets. We need to break the rules that nature has set. We need to talk about how time can compress and stretch, about what will happen if we can fly at the speed of light itself. We have spent decades on the road, using only primitive chemical engines. In fact, our best rockets are just very complex firecrackers. But what if we change the rules of the game? In laboratories today, they are testing technologies that can turn years of suffering into short walks. Ion engines, which accelerate slowly but can work for years, they do not create a powerful burst. If you put one in your palm, you will feel a pressure equal to the weight of a single sheet of paper. On Earth, this seems useless, but in a vacuum, where there is no air resistance, this tiny, barely noticeable push can last for years. The Dawn spacecraft, which explored the asteroid belt, used precisely this force. It accelerated slowly, centimeter by centimeter, but after months of continuous work, its speed exceeded the capabilities of any chemical rocket. It is the marathon runner of space, but even the ion engine is only the beginning. The real breakthrough awaits us in the field of nuclear energy. We are used to fearing the atom, but in deep space, it is our only chance for speed. Project Draco, which is now being developed by NASA and the DARPA agency, is an attempt to create a nuclear thermal engine. Its principle is simple and brilliant. We do not burn anything. We just pass liquid hydrogen through the red-hot core of a reactor. Hydrogen instantly expands and bursts out of the nozzle at incredible speed. This gives us 3 times more thrust than the best chemical engines of today. With such power, we will be able to fly to Mars not in 7 months, but in 3. This changes everything. Cosmic radiation simply will not have time to kill the crew in such a short time. But this is still movement within the system. What if we want to reach speeds that seem impossible? Here, solar sails come onto the stage. This is the most romantic and at the same time the most insane idea of humanity. We are building a giant mirror canvas, thin like a cell membrane, and with an area of several football fields. It is not pressed by the wind, it is pressed by photons, particles of light. The sun literally pushes your ship away from itself. This is free and endless energy. But what if we replace the sun with a giant array of lasers on Earth? This is Project Starshot. The idea is to direct a beam with a power of 100 gigawatts at a tiny sail weighing 1 gram. Theoretical calculations show that such a nano spacecraft can be accelerated to 20% of the speed of light in just a few minutes. At this speed, you will fly past Pluto 3 days after launch, and in 20 years, you will reach Alpha Centauri, another star system. But it is here, on the threshold of great speeds, that we face something that cannot be bypassed by any engineering tricks. We face the laws of the universe itself. Albert Einstein left us a border that cannot be crossed. The speed of light, 300,000 kilometers per second. Let us conduct a thought experiment. Imagine that we have built a ship capable of moving at almost the speed of light. You press the gas. At this moment, the world around you begins to distort. The stars in front of you change color, becoming bright blue, and those that are behind turn red. Space begins to contract. Distances that seemed insurmountable suddenly shorten. But the most terrible thing happens with time. This is called relativistic time dilation. For you inside the ship, time flows perfectly normally. You feel the rhythm of your heart. You see, as the second hand on your watch makes its usual circle. But for an external observer, for people on Earth, your watch has almost stopped. Imagine that you decided to make a flight to Neptune and back at a speed of 99% of light. The journey there and back at this speed will take about 8 hours of light time. You drank a cup of coffee, watched a long movie, and returned to Earth. You come out of the hatch, expecting that only a few hours have passed. But you see another world. Your friends have become old men. Your children are older than you. The buildings that you knew have been demolished. On Earth, years passed while you watched a movie in your cabin. This is not magic and not science fiction. This is a mathematically proven reality of how our universe is structured. Time and space are linked in a single fabric, and high speed literally stretches this fabric like rubber. And even at this, seemingly divine speed, The cosmos remains frighteningly huge. At the speed of light, a flight to Pluto is still 5.5 hours of waiting, 5.5 hours, during which you will see only endless void. Even light, the fastest thing in the universe, seems slow when we try to measure the abyss between planets with it. We started this story with the question, how long will the journey to each planet take? And now we understand that the answer depends not only on our engines, it depends on how much of our life we are willing to give for this knowledge. The cosmos is a giant machine for grinding time. We build spacecraft that will survive our civilizations. We send signals that will fly in the void for millions of years after the last person on Earth falls silent. We are just a flash in the dark. But in this short second of our existence, we have learned to build machines that overcome millions of kilometers. We have learned to look beyond the edge of the horizon and count the hours to Pluto. Maybe, someday, our descendants will look at our current rockets as the primitive canoes of ancient people. They will jump between planets in hours without thinking about the difficulties, but they will always remember that we were the first. Those who were not afraid to spend years of life just to see what Saturn looks like up close. Our time is up, but the time of the universe is infinite. And somewhere there, among icy rings and dust storms, our small spacecraft continue their eternal run. In silence, in the dark, waiting for those who will come to replace them.